So I thought to myself, how in the world can I do the last day of class without doing a live video for you? So that's what I'm going to do today. I would love for any of you who've listened to this video, just please just send me an email and just let me know that you got the email or got the message that I really, really miss you guys. And I'm sorry this year had to turn out this way, but we're all going to be stronger for it. And we're going to get through this and be better people in the end. And you know that that's the number one reason why I became a teacher is to make you all better citizens of the world. So be strong during this time and be resilient and keep being good people, okay? So let's get to Unit 10, Lesson 7 is the last unit we're going to be doing in this class this year. We didn't get through everything, but that's okay because I'm getting through this last topic that I want to do, and then we're done. So linear regression is when we're comparing two pieces of data. So I asked you guys to make sure that you know how to do the correlation coefficient. Definitely take a look, please, at the materials under Unit 10 and make sure your calculator has it turned on because you will not be able to do the work if you don't have it turned on. And you'll say, Mrs. J, I didn't have the information. I'll say, please look at my video. Thank you. It's really quick. So make sure you have your calculator, please, today. If you don't, make sure you have it downloaded because I gave you that earlier in this session. So they're saying that we were using a scatter plot to create an equation to find an equation. We're going to use our calculator to find the equation, which is going to be really, really precise. In the previous lesson, we were getting an estimate, which is fine. This is going to be precise. So let's go through this. It says a survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try and establish a relationship between days' low temperatures and high temperatures. Enter the data list into your calculator and create a scatter plot using the graphing technology. I'm going to show you how to do that without doing the second thing, which is to size the window. I'm going to show you how quickly and easily we can do it. Again, benefits of being a stats teacher, right? Go to your calculator, please. You're going to make sure that you don't have data in your computer, in your calculator already. How are you going to do that? You're going to go to, let me make sure we're clear on this, go a second quick. So you turned it on. You're going to go to Stat, and you see where it says Edit. You're going to choose Edit. Now, I have a ton of work because obviously I teach stats and I'm doing work with my students all the time. You might have information in there because you might have used it, obviously, in other classes, in my class, or you might be using someone else's calculator. If there's data in there, we're only going to be using L1 and L2. You would go to the top of the screen. You see where it says L1, and you're going to hit clear. Don't hit delete. Hit clear. Okay? It cleared L1, and when I hit arrow down, it's blank. Do not hit delete. Okay? Go over to the other one, L2. I'm going to hit clear, and I'm going to go down, and now it's gone. And if it's freaking you out that everything else is there, I'm just going to clear them out too, so that way you are good to go. Okay, so we're going to be doing L1 and L2. So let's put the data in. Just go ahead and do that. You can fast forward ahead if you've already done it. 35, 37, 38, 41, 45. Make sure you typed it in right. You can see I didn't do all these right. That's what happens. I go too fast. 30, 32, 34. By the way, they have to be in the same order because these pairs go together because the data is a high and low temperature for a day. So you can't put, if it was 41 for a low, you can't put it with a number that wasn't the high of the same day. Okay, so now I've gotten that better. Sorry about that. I'll be more conscious of that. Let's put in the high temperatures now in L2. Hopefully these are right. I don't want to spend too much time making sure I did it right as far as transposing numbers or whatever, but it looks like it's good. Okay, now create a scatter plot. This is what you're going to do. And we're going to show you how to turn it off too, because when you're doing stuff over the summer or next year, you're going to say, my calculator doesn't work. So we're going to go to second, stat plot. And some of you might have seen this over your career in algebra. And you're like, what is this? And I'm like, oh, just get out of it. Hit escape. Get out of it. I go to stat plots and see how all of mine are off. All of yours should be off right now too. I'm going to hit enter on number 1 and I'm going to turn it on. Now, what am I going to turn on? Let me look at these little things under this type. The first one obviously looks like a scatter plot. What's a scatter plot? It's a plot of 2 points that is making dots across the whole page. So let me choose that one and let me see if it looks like what I want. And sure enough, it does. You see how it has a scatter plot. The other one's a line chart. We don't use line charts in stats. We don't. It's cute to look at, but it just says it's not used. So L1, L2. L1 is my X value, L2 is my Y value. Why is X L1? Well, what's basically saying is if the temperature in the morning was low, what would the expected afternoon temperature be? And in general, we would say it's probably going to be lowish too, versus if it was like today, it's warm out, where right now it's warm out, especially to be really hot today. So how do I get to my graph? Ready for this? We're going to hit zoom. And we're going to choose 9, which is zoom stat. This is going to be a stats graph. Okay. If you have anything in Y1, it might be showing up here. Don't worry about it. You can always delete what's in Y1 by going to Y1 and clearing it out. Mine's not showing because it's such a big graph. Do you see how plot 1 is highlighted? That means that I now have that plot there. So it's going to mess up things going forward. I'll show you how to turn it off in a moment. So I'm going to hit zoom 9 again. Okay. There's my data. And it asks us to compare it to the previous lesson's graph. So take a look at your previous lesson, see how it looks. It should look the same, right? So fine, so we're good. So they want to create the plot using graphing technology. They didn't ask us to graph it, so I'm not going to, but sometimes they'll actually say, can you graph it? And you'll kind of make a little quick graph. Let me see if I can do it real quick. And it doesn't have to be perfect, but I would kind of do something like this. Right? I do something like that. It's good enough. It kind of shows the reader what's happening. All right. So that's what I would do if it asked for that, but it didn't. So let's move on to the next question. Okay, using your calculator to find the equation of the line of best fit, round the slope of the line to the nearest hundredth and the y-intercept to the nearest integer. Compare the slope you found in the last lesson. So let me show you how to do that. Use your calculator to find the equation for the line of best fit. So far right now, we've put our data into stat edit. Then we went to the scatter plot, which is going to be second stat plot. And I made sure that it was the scatter plot for y1, y2. Which was L1, L2, sorry. And now I'm going to go to stat, calc, and I'm going to go down to linreg, which is number 4. Okay. Now it says AX plus B. That's going to be an equation of a line, right? Y equals MX plus B, the A instead of the M, yes. So L1 is going to be my X's, L2 is going to be my Y. Don't worry about that. Usually it's going to be in order. In this stage of the game, we don't have to worry about what's X and what's Y. Don't worry about the frequency list. Don't worry about the store. It's going to be blank, not a 0, just blank, and hit calculate. And look what happened. It actually created for me an equation. So what I'm going to do is I'm going to write it down. I'm going to write Y equals 1.9, sorry, 1.1, sorry about that. How do I erase this? There we go. When it's small, I don't know where is it. 1.16x plus 19. It says to the hundredth for the slope and nearest integer for the y-intercept. Fabulous. So let me quickly open up my data from the previous day. Give me 1 second. And let's see what that was. You guys have it in your book too. Let's just see what that was and do a quick comparison to see how close we were. And what should happen is you're going to be pretty close. Maybe you said that the slope was 2. Maybe you said the slope was 2.2. I'm fine with that. Maybe you said the slope was 1.4. I'm fine with that. But you know what I'm not fine with? I'm not fine with the slope being negative. I'm not fine with the slope being 3. Right? So we have to make sure that we have a pretty good slope. So let me just go through and show you. So when I did this last year, I had a slope of 1.21. Pretty good, right? So the fact that it was 1.16, it's not that far off. It's completely fine. We're estimating when we're doing the scatter plot and trying to draw a line of best fit, because we're trying to get it through 2 points, the calculator does it exactly for us. So the bottom line is, did I end up having a full equation? They didn't have me do the full equation? Huh. Okay, so the full equation, I then would have taken the 1.21, I would have picked 2 points, and I would have found the line equation. Do I do it? Maybe I have it down farther. I don't know. I didn't. Okay, whatever. All good. And that's that. So the slope here was 1.21. That was mine. Yours might have been different. Explain why the y-intercept in this model, what the y-intercept of this model represents in terms of the low and high temperatures being modeled in the problem. So this is what we're going to say. So the y-intercept, if, let me write it, if the low temperature for the day was 0 degrees Fahrenheit, right? We would expect a high temperature of 19 degrees Fahrenheit, okay? Because if we put in 0 for X, that means that if the low temperature was 0, the high temperature would be 19, okay? How do you interpret the slope of this model in terms of how the low and high temperatures change with respect to each other? So what we're talking about is here, remember, slope is going to be the change in y over the change in x. So what I'm going to do is I'm going to say for every 1 degree change in low temperature, the expected high temperature, would increase by 1.16 degrees Fahrenheit. Okay. I'll write Fahrenheit here too. Okay. So, and I need to say increase because it's positive. If the slope was negative, which is negative slope is completely fine, we would then see it going down. Okay. Fabulous. Let's move on. So now we're talking about weight of a car and the gas mileage. And as I'm sure you can appreciate, a really tiny car, think like a Honda Civic or a Toyota, I don't know what the smallest ones are. Camry's bigger than I don't know what the smallest one is. A really small car. They get really good gas mileage. They don't weigh a lot. Probably could get 2 or 3 of your friends together and they could probably lift it up, right? Versus a Hummer, a giant big, or a Suburban, a really big car is going to be heavy and it's going to get really low gas mileage. While it has a big gas tank, it's going to get low gas mileage. Okay. So it's saying that I'm going to look at this table real quick. It's talking about weight in thousands of pounds. This is important because obviously we know a car does not weigh 3.7 pounds. It weighs 3,700 pounds. Cars are over a ton, right? And then the miles is miles per gallon. Find the equation of the line of best fit using your calculator, round both to the nearest tenth. Then list what the variables are. You have to tell the reader what the X and the Y are. And then this one, we'll be able to do it pretty quickly. So given the weight of the car, what is the gas mileage is what it's saying. So I'm going to do stat edit. I'm going to clear out my L1, L2. So I'm going to go up to L2, clear it, down, arrow over, up to L1, clear it, L1. If by chance you deleted, please do not delete. If you did, shoot me an email. I'll send you a video on how to get back your data, okay? All right. So we're going to do first the weight. Please follow along, do it with me. Don't just stare at what I'm doing because you need to know how to do this. You need to be comfortable with the calculator. So when we do, this is kind of cool because we're like, oh, wow, we're using more things on our graphing calculator. My family did not waste their money buying me one because there are things we've been doing, especially in the last half of the year, that we need a graphing calculator for. And there's a whole section of the calculator on the stat button that is doing all the statistical analysis. And again, we use the stat button almost exclusively in AP stats. So find the best fit line. So I'm going to go to stat, calc, and I'm going to go to number 4, linreg, linear regression. Linear regression means it's comparing two pieces of data and trying to draw a line. Linear regression. So L1, L2, I'm going to hit calculate. And they want us to round both to the nearest tenth. So let me go and close this down and do that. So first thing I'm going to do is I'm going to do y equals negative. Make sure you do that negative. 8.1, that's what it rounds to, x plus 68.1. Okay. Now, what's the x value represent? The x value represents x equals the weight in thousands of pounds, right? And the y value, y is the expected mileage, miles per gallon. Okay. All right. Create a graph of the scatter plot for this data. Would you consider the correlation between weight and mileage to be positive or negative? Explain. So go to second stat plot. Mine's still on, but I'm just going to look at it real quick just to make sure we're good with this. We are on. The type is scatter plot, L1, L2, and I'm going to hit zoom 9. Now it's going to take the data that I just had, and I'm going to change it to the miles and the weight. So create a scatter plot. It doesn't say to draw it. I'm going to draw it because I really would like it to say create one because it's important to start doing. Boop, 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 boop. Good enough. Okay. Would you consider the correlation between weight and miles be positive or negative? Well, the correlation as the weight of the car goes up, right? This is weight down here. This is weight. This is pounds. And this is the miles per gallon, right? As the weight goes up, the miles per gallon goes down. So yes, I would consider the correlation to be negative. Why? And I would say exactly what I just said. When weight goes up, miles per gallon goes down. Okay, which would be a negative relationship. And again, negative is fine. Negative isn't a bad thing. It's not negative, it just is. Negative is. All right, so it's negative. That says negative. Which parameter of the linear model predicts whether the correlation is positive or negative? Use this model to help explain your answer. So look, the slope is negative. So when the slope is negative, that tells me that I'm going to have a negative correlation. So the slope tells us whether something is negative or positive. In this case, the slope of negative 8.1 confirms we are a negative correlation. Okay. Make sure we're good with that. Maybe it's a little bit smaller. All right. The slope tells us if something is negative or positive. In this case, the slope of negative 8.1 confirms it's a negative correlation. We have a negative correlation. How about that? Finally, if a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency round to the nearest integer? Now be careful. Remember, our data had it in thousands of pounds. The data was in small numbers. So if we're going to say that a car is 4,300 pounds, we're going to change it to our x value is going to be 4.3 pounds. Let's use that in our equation. Let me write it out. So I'm going to write my equation as y equals negative 8.1 times 4.3 plus 68.1. I'm changing the X value to 4.3. What am I going to do now? I'm going to go to second quit on my calculator and I'm going to type it in. Negative 8.1, if I can do 8.1 times 4.3 plus 68.1. Enter. So it's saying that if I have a car that weighs 4,300 pounds, my fuel efficiency, it says round to the nearest integer, is going to be 33 miles per gallon. It says use appropriate units and make sense of your answer. Okay? Now, let's do the flip-flop. If we want to purchase a car that got 40 miles per gallon, what weight should we have to the nearest 100 pounds? Solve algebraically. So again, let's take our equation and let's flip-flop it. So now I'm going to take the 40 and plug it in for my y value. This should be a y, by the way. I didn't bring it all the way down. Y 40 equals negative 8.1x plus 68.1. And let's do the math. How are we going to do this? Subtract. So 40 minus 68.1 is negative 28.1 equals negative 8.1x. Then we're going to divide by negative 8.1. This is how it's going to become positive, right? Because we can't have negative weight. And we're left with 3, what they want us to do, round to the nearest 100 pounds. So I'm going to do 3.4691 equals x, okay? It says 100 pounds. So now remember, I had to multiply this number by 1,000, right? Because this was in thousands, times 1,000. And it says round to the nearest 100 pounds, okay? 100 pounds. So let's figure out what we're going to do here. So let's round it to 100 pounds. I'm going to go to the 100 place, which is going to be this 4, but it's going to round up. So 3,500 pounds the car would be. Okay, fabulous. So the last thing I want to do is turn off for you the stat plot. So you know how to do that. Go back to second stat plot, and we're going to turn it off. So go to the first one and turn it off. Okay, so now if I go back to y equals, you can see that all my stat plots are off. Okay, I wanted to, unfortunately, I don't know how to get back to my screen to say thank you guys so much for a great year. And I love every minute of teaching. I love every minute of helping you guys be better humans and be good citizens. And you have a wonderful summer, and I will talk to you all soon. Bye now.